So here is a problem that I want to work. And so I've taken this series, I goes from 1 to infinity, 1 over I times I plus 1. And I've split it up into subtraction of two fractions. We're using partial fraction, yes.
Why do you want to use partial fraction?
You know why? If I look at some partial sums of this, the way it's written here, I might not be able to get a good handle on what's happening. I might see it looks like it's converging, or maybe with some other test I could tell for sure that it's converging, but I might not be able to quite tell what it's converging to. Partial fractions would just give us a better look at the sum. So, and in this part of the book, and almost any calculus book you pick up on this, they follow the same sort of thing. Like they'll have this right here around section 11.2, and then in 11.4 of your book, they do the comparison test, and you can actually show from here, from the way it's written first, you could show with the comparison test that this series converges. But with the comparison test, you're not going to get the sum, or you're not going to get an exact sum. So let's go with the partial fraction here. Does the series converge or diverge? So for the solution, for part A, I'm going to look at some partial sums. So S1 is what I get when I plug in 1. And I'm going to go with my partial fraction decomposition. 1 over 1 minus 1 over 1 plus 1. And I could get a number there. 1 minus 1/2 is 1/2. S sub 2 would be 1 over 1 plus 1 over 1 plus 1 plus 1 over 2 plus, oh, that's a minus, isn't it? Let me correct that. 2 plus 1. Let me correct that in red here. Oh, let's just put a negative right there. All right, that takes care of that. So 1 minus 1 over 2 plus 1/2 minus 1 over 3. That becomes 1 minus 1/3. So that would be 2/3. And then S sub 3 would be 1 over 1 minus 1/2 plus the second term, 1/2 minus 1/3, plus the third term, 1/3 minus 1/4, and that's going to be 1 minus 1/4, and that would be 3/4. And show a few of these until you've established the pattern, till you kind of see what's going on. I'll do ... What is S sub n? That's going to be 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus ... and it would be 1, let's see, if I plug in 1 over n minus 1 over n plus 1. And then what collapses out of this? Negative 1/2 with 1/2, negative 1/3 with 1/3, negative 1/4. The next one would be positive 1/4 right here. And the one right before 1 over n would be that negative 1 over n. So S sub n is 1 minus 1 over n plus 1. And so the sum S is defined as the limit as n approaches infinity of s sub n. So the sum s is the limit as n approaches infinity of 1 minus 1 over n plus 1. Let's separate this. So I continued it over here. And this would be equal to what? That equals 1. So the sum equals 1. We've answered part B. Because does it converge? Yes. And if it converges, can you find what it converges to? This converges to the number 1.